Q5198. By changing the angle of attack of a wing, the pilot can control the airplanes. A. Lift, airspeed, and drag. B. Lift, airspeed, and CG. C. Lift and airspeed, but not drag. The correct answer is A. By changing the angle of attack of a wing, the pilot can indeed control the airplane's lift, airspeed, and drag. The angle of attack refers to the angle between the wing's chord line, a straight line connecting the leading and trailing edges of the wing and the oncoming airflow. When the pilot increases the angle of attack, it increases the lift generated by the wing. This is because a higher angle of attack increases the pressure difference between the upper and lower surfaces of the wing, resulting in greater lift. Changing the angle of attack also affects the airspeed of the airplane. When the pilot increases the angle of attack, it can cause an increase in drag, which is the resistance experienced by the airplane as it moves through the air. The increased drag can result in a decrease in airspeed unless additional engine power is applied. Therefore, by adjusting the angle of attack, the pilot can control the lift, airspeed, and drag of the airplane, allowing for changes in altitude, speed, and maneuverability. 5198-1. An aircraft airfoil is designed to produce lift resulting from a difference in the A. Negative air pressure below and a vacuum above the airfoil surface. B. Vacuum below the airfoil surface and greater air pressure above the airfoil surface. C. Higher air pressure below the airfoil surface and lower air pressure above the airfoil surface. The correct answer is C. An aircraft airfoil is designed to produce lift by creating a pressure difference between the upper and lower surfaces of the airfoil. The shape of the airfoil, with a curved upper surface and a flatter lower surface, causes the airflow to move faster over the top surface compared to the bottom surface. According to Bernoulli's principle, as the airflow velocity increases, the pressure decreases. Therefore, the airflow above the airfoil has lower pressure, while the airflow below the airfoil has higher pressure. This pressure difference creates an upward force called lift, allowing the aircraft to generate the necessary aerodynamic force to stay in the air. 5199. The angle of attack of a wing directly controls the A. Angle of incidence of the wing. B. Amount of airflow above and below the wing. C. Distribution of pressures acting on the wing. The correct answer is C. The angle of attack of a wing directly controls the distribution of pressures acting on the wing. The angle of attack refers to the angle between the wing's chord line, a straight line connecting the leading and trailing edges of the wing and the oncoming airflow. When the angle of attack changes, it affects the way air flows over and under the wing. Increasing the angle of attack increases the pressure difference between the upper and lower surfaces of the wing. This leads to a higher pressure below the wing and a lower pressure above the wing. The distribution of pressures acting on the wing is crucial for generating lift. The pressure difference between the upper and lower surfaces creates an upward force, known as lift, that enables the aircraft to stay airborne. Therefore, by adjusting the angle of attack, the pilot can control the distribution of pressures acting on the wing and thereby regulate the lift produced by the wing. 5239. When the angle of attack of a symmetrical airfoil is increased, the center of pressure will A. Have very limited movement. B. Move aft along the airfoil surface. C. Remain unaffected. The correct answer is A. When the angle of attack of a symmetrical airfoil is increased, the center of pressure will have very limited movement. In a symmetrical airfoil, the shape of the upper and lower surfaces is the same, resulting in an equal distribution of pressure around the airfoil. As the angle of attack increases, the lift force also increases, but the center of pressure remains close to the quarter chord position, which is typically located around 25% to 30% of the chord length from the leading edge. This means that as the angle of attack increases, the center of pressure may experience some minor movement, but it generally remains relatively close to its original position near the quarter chord. Therefore, the movement of the center of pressure is limited when the angle of attack of a symmetrical airfoil is increased. 5200. In theory, if the angle of attack and other factors remain constant and the airspeed is doubled, the lift produced at the higher speed will be A. The same as at the lower speed. B. 2 times greater than at the lower speed. C. 4 times greater than at the lower speed. The correct answer is C. The relationship between lift and airplane velocity is that of the square. For instance, provided the angle of attack and other variables remain constant, an airplane traveling at 200 knots will have 4 times the lift of the identical aircraft traveling at 100 knots.